In this video, we want to use our understanding of conversions and dimensional analysis to calculate the number of milliliters that someone would consume. And so in this picture, we are given a variety size of volumes here. We have a liter bottle, we have 12 ounces of juice, 8 ounces of Ensure, a medicine bottle that has 8 tablespoons, and a medicine cup that has 30 milliliters. And what we want to do is to just make the assumption that somebody consumed liquid from all of these containers. So they consumed everything. And what we want to know is how many total mLs of fluid would they have consumed if they consumed fluid from all of these containers. So we're just going to go through and convert each one of these into milliliters and add them all up, and that'll be the total intake. Now, some of these, if we are focusing on milliliters, may not require as much work as we would expect. For example, we already have 30 mLs. This medicine cup has 30 milliliters of fluid. So that means there's no conversion necessary there. 1 liter, we need to know in our course that 1 liter is 1,000 mLs. So there's really no conversion necessary there. So all that really needs to be done is we need to convert 12 ounces, 8 ounces, and 8 tablespoons all into milliliters. And I'm going to do so using dimensional analysis. So if I look at this, these first two containers, or the second and third container, the juice and the Ensure, if I add 12 and 8 ounces, they're the same unit, I see by consuming that liquid, they're getting 20 ounces of fluid. So if I'm using dimensional analysis, what I'm going to do is to start with what I want to change, what I want to convert over 1. And my mind here is thinking that I want to convert ounces into milliliters, and that is a conversion that I know. So I can go directly from ounces to milliliters. That's something that I need to know. Using dimensional analysis, I'm going to multiply by a conversion factor where I'm turning those ounces. I'm going to cancel those out and go into milliliters. Notice I'm focusing on the units first. And now what is the relationship? I know that 1 ounce is 30 mLs. So now all I want to do here is to multiply 20 times 30, and I will get the number of milliliters in 20 ounces. And so what we should get here is that this is 600 mLs. 20 times 30 is 600. So there's 600 mLs in 20 ounces. So I'm going to go ahead and just put a little box around that to remind myself that's good to go. The last conversion I want to focus on here is to turn these 8 tablespoons into milliliters. So I want to go from tablespoons to milliliters. I need to think, is that a conversion I know? It should be. There are no intermediate units. There's no tablespoons to teaspoons first. We can go directly from tablespoons to milliliters. In fact, what I know is that 1 tablespoon is equivalent to 15 mLs. So I'm just thinking through the problem before I jump into the math. Now actually converting those, if we're using dimensional analysis, I'm going to go ahead and take those 8 tablespoons and write them over 1. And because I've already thought through what I'm going to do, I want to turn tablespoons into milliliters. And if I multiply by a conversion factor with tablespoons in the denominator, that'll help me do that. I know that there are 15 mLs in 1 tablespoon. And so what I'm going to do is to multiply the numerators, divide by 1 times 1, which is just 1. So 8 times 15, we get that there are 120 mLs. There are 120 mLs in 8 tablespoons. And so now I'm just going to go back and find the total intake by summing all of those values. So the water bottle has 1,000 mLs. The juice and the Ensure, I calculated those ounces into 600 mLs. The medicine bottle was 120. And finally, the medicine cup was 30. So I'm going to go ahead, and add all those up. So in my calculator, just to be safe, we may not need a calculator, but if you have one, go ahead and use that. 1,000 plus 600 plus 120 plus 30, we get 1,750 mLs. That is the total intake. if somebody consumed liquid from all of these containers. Now let's look at one more example. In a nursing situation or in a clinical situation, we have here charted amounts of liquid that somebody consumed. And so we see here at these various times, the intake, the amount of liquid that an individual consumed is being charted. And what we want to do is to calculate and convert all of these into milliliters. Our focus is on converting these into milliliters. Now this particular intake chart gives us some common conversions up top. So just a few things that I want to point out about this. A juice glass in this situation, and this could be just consistent with this institution, is 180 milliliters. That doesn't mean that every single juice glass across the United States or the world is 180 milliliters, but we are given, at least at this institution, that's the size of a juice glass. Same thing with the water glass, coffee cup, soup bowl, milk carton. Gelatin, although you might think that's a solid, if it were to sit at room temperature, it would turn into liquid. So a gelatin cup is actually liquid. That's going to be 100 milliliters. Now, what makes this a little bit different than what we just did is that the individual who is consuming these items that have been charted did not consume all of it. They consumed part of it. So what I see here is this individual consumed about 80% of their gelatin. So that's the first thing I'm going to do, is to figure out if they consumed 80% of their gelatin, what is that? So if I look at the items that are given to me, up top here on my chart, a gelatin cup is 100 mLs. So I need to find 80% of 100 mLs. So I'll take 0.80 times 100. The gelatin is going to be 80 mLs. And this 80% would be an estimate based on the provider who's there and charting this. So that was just an estimate that they made. So by consuming 80% of their gelatin, they had 80 mLs. If you want to pause the video and go ahead and try at least the coffee and maybe the medicine, there is another piece in this that we haven't described yet, which is working with rates. But if you want to go ahead and pause the video and do that, please feel free. I'm going to keep going. And actually, maybe I'll put 80 mLs here as the amount of gelatin. Half the coffee. So half of the coffee, we need to be able to work and operate with fractions and percents and decimals. So if I look at the coffee cup is 240 mLs. So I have 1/2 times 240 mLs. If I multiply that, I get 120 mLs. I'm going to skip over the volume for the fluids right now for the rate and go to the 3 tablespoons of medicine. We saw in the previous slide that 1 tablespoon is 15 mLs. So using dimensional analysis, I want to start with what I want to convert. I know 1 tablespoon is 15 mLs. I'll have 3 times 15, which is 45. So this individual consumed 45 mLs. I might as well put a box around my 120 as well. 45 mLs of medication. Finally, what we have here is a rate. A patient is receiving fluids continuously as an infusion, which we'll talk about more in this course in a few weeks. They're getting 35 milliliters every hour, and this has been operating for 4 hours. Now, there are a couple ways to approach this, and I'm going to show you 2 ways. One is just to use our understanding of proportions. And we've seen problems like this already. If somebody is receiving 35 mLs in 1 hour, well, at that rate, if it were to continually operate for 4 hours, then what I want to address here and answer is, if it's operating at 35 mLs per hour, well then, for 4 hours, how many mLs do they receive? This is a missing value proportion that you should be able to solve. So if we think back to the various methods that we went and addressed, you could use cross multiplication. I see here the hours are just increasing by 4. So that means the milliliters are going to increase by 4. And 35 times 4 is 140 mLs. Now, using dimensional analysis, and we're going to see this a little bit more as we approach the remaining dosage units, what I want to do here is to start with the rate. So I'm going to write out the rate of 35 mLs per hour. And what I want to do is to multiply by the number of hours. And the reason I want to do that is because I want just milliliters. I don't want milliliters per hour. I want to convert milliliters per hour into just milliliters, which means if I were to multiply by a factor where I multiply by the number of hours, then those would cancel. We think what we learned this week about dimensional analysis and focusing on the cancellation of units. And I'm not turning those hours into anything. I'm just eliminating them. I'm canceling them. And so I'm just going to put a 1 here in the denominator to remind myself that I'm not converting those hours into minutes or hours into days or hours into anything. I'm just eliminating the hours. So I'm going to multiply by hours. And what I see here is if I take 35 milliliters per hour, multiply by the number of hours, then hour cancels in the denominator, and I'm left with just milliliters. 35 times 4 is 140. We get exactly what we got up above. So as we start to work with dimensional analysis more, this might be an approach that you take, where you're not converting those hours into anything, you're just multiplying to eliminate that unit. And dimensional analysis allows us to think really deeply about the units, multiplication and division, focusing on canceling those units. And so by that infusion running, this individual consumed 140 mLs right there from their infusion. And now I'm going to go ahead and add all those up. So if I look here, put them in my calculator. I don't think I need a calculator here. 80 and 120 is 200. 140 and 45 is 285. So assuming I did that right, that would be 485 mLs. And I am just going to put that in my calculator because I have one and I want to be 100% sure. Oh, see, that's why I use my calculator. 140 and 45 is actually 185, so I should get 385. Always good to check if you have a calculator. So 80 and 120 is 200, and if I add in those additional values, I get 385 mLs as my total intake. Just to reiterate here as we move forward, this problem illustrates the fact that we're going to have to take our conversions, and sometimes we'll have to multiply those, at least for these first two, by a decimal or a percent or a fraction, especially if the individual did not consume the entire container of gelatin or coffee or soup, whatever the case might be. So just reflect back on how we operated with those items, and now we're adding them back into these conversion problems.